Let's just give that a sec there. Let's just give it. Just 1 second here. Sorry, folks, I'm having a slight technical problem, and it's just going to take me a minute to get fixed one little thing, and then we'll get started. Just 1 second here. Okay. So welcome. Sorry, folks, I'm having a slight technical problem, and it's just going to take me a minute to get fixed one little thing, and then we'll get started.
It means YouTube is working.
Here. Yeah, I'm not. I'm getting some feedback. Are you guys hearing feedback?
Not right now.
All right, good. Let me start the share again. So sorry about that. Well, all right, welcome everybody. This is the presentation of our 2022-2023 research scholarship projects from our wonderful 4 winners of our research scholarships. So welcome everybody. But before we get started, I would like to acknowledge that the work done by the Santa Clara Valley chapter of CNPS lies in the homeland of the Muwekma Ohlone, the Amamutsin tribal band, the Tamiyan Nation, and the Ramayatush Ohlone, who still live and thrive in this area today. We hope to learn from them and support their work to restore traditional practices and heal from historical trauma. If this is your first talk, we would love to know how you found out about us and where you are. So if you're comfortable with it, please share that in chat. And these talks are not just done by one individual. It takes a whole team. And tonight, I'm obviously your host. We have Judy Fenerty, who is our Q&A moderator, Madeline Morrow, who is our YouTube moderator. So for those of you who are on YouTube, Madeline will be monitoring the chat. So if you have any questions, you can type them into chat, and Madeline will make sure that we over here on Zoom know what they are and they get answered. And I'm also taking care of the tech behind everything. And we have our wonderful 4 students, Krti Tallam, John McLaughlin, I hope I pronounced that right, correct, Sierra Phillips, and Andy Frank. If you are not familiar with CNPS, we are a nonprofit organization founded in 1965. We have over 11,000 members in 36 chapters, which are spread all over our state and beyond our borders, beyond the country's borders, because we also have a chapter in Baja California. Our chapter is the Santa Clara Valley chapter, which covers all of Santa Clara County and southern San Mateo County. The CNPS mission is to protect California's native plants and their natural habitats today and into the future, and we do that through science, education, stewardship, gardening, and advocacy. If you're not currently a member, we would really welcome your support of our movement to conserve South California's native plant diversity. And once you become a member, you get 2 wonderful journals, Artemisia, which is a science-based journal, and Flora, which has more general interest articles. You'll also receive our chapter's newsletter, The Blazing Star, which tells you about upcoming events, as well as has interesting articles about local happenings. And you get discounts at local nurseries. It's very easy to join. Just go to cnps.org/join. You can use that QR code there to get there and sign up online. It's very fast. We have a lot of events coming up. just on Saturday, you can go to Lake Cunningham and join Arvind doing restoration at the native plant garden there. There's another session next Saturday as well, and that's at 8 in the morning. We have a photo group meeting coming up on May 26th at 7 o'clock. That's really fun. If you have any photos, you're welcome to join the photo group to share your photos. But if you simply like to look at beautiful pictures and find out about interesting places to visit, the photo group is a wonderful place to do that. And that is virtual meeting. So you just need to go on our website and you'll get information on how to join it. We have a virtual talk coming up at the beginning of June, Pollinator Restaurants and Building Community, which is by Jennifer Durking. That'll be on Zoom and YouTube, just as our talk tonight is. We also have an in-person talk. So now this one will not be online. The Power of Native Plants, a talk which is by Juanita Salisbury. That will be at the Los Altos Library on June 14th at 7 o'clock. So that will be a great talk, but you do actually have to go to the library to see and hear it. And then our field trip, our next field trip will be on June 25th, which will be a first day of summer bird and plant ID walk at Lake Cunningham. And we always have more things getting scheduled. So there may be other things that are not on this slide coming up in the next month. And the easiest way to make sure that you find out about them is to be on our chapter news mailing list. I'll provide a little bit more information about that later. But there are 2 QR codes here. One is for our website, one is for our meetup group, and those are 2 other places that you can keep abreast of what's coming up in our chapter. We also have a nursery where we have periodic pop-up sales, and this is the source of our most of our chapter's funding. So we really appreciate it when people buy plants from us. We announce our pop-up sales to chapter members. We will have one more sale toward the end of May. And if you are a member, you'll get email notice when that happens. And that will be actually our last sale before we go on our summer break. So if you're interested in buying plants from us, do keep aware of it. And best of all, become a member so you'll get the notice. And in addition to plants, you can also get t-shirts and books, and that's all available for purchase online. And then you either come by the nursery to pick it up or have it delivered. And as I mentioned before, the best way to stay abreast of what's going on with our chapter is to make sure you're on our chapter news mailing list. That's an announcement once a week and occasionally other messages as well. Very easy to join. It's a Google group. You can just send a message to this email address at the bottom of the screen, or you can go on our web page, cnps-scv.org, and there's information there as well to tell you how to do that. And now a little bit of housekeeping. Before we get started on our program tonight, I would like you to please mute your microphones. If you have any questions for any of the speakers at any time, please feel free to type them into chat. Doesn't matter if you're on YouTube or Zoom, we're monitoring both. And we have Judy who will be reading those questions to the speakers at an appropriate time. We do expect to finish the program by 9 o'clock. And as I mentioned before, this is both on YouTube and on Zoom. On YouTube, it will be available immediately for later viewing, so you can share it with a friend or view it later again if you'd like to. And before our students' talks, we have a Spotlight Award to give tonight, so I'm going to turn it over to Arvind.
Thank you, Vivian. Hi, everyone. My name is Arvind Kumar, and together with Priya Parate, I'm the co-chair of the chapter's Volunteer Recognition Committee. We are very pleased to announce tonight that the Volunteer Spotlight Award is going to someone intimately involved in putting together today's program, and that is Karen Carter. Congratulations, Karen. I just want to give you a brief background on Karen. Karen has a master's degree in conservation biology from San Francisco State University. She worked as research director at Actera and later at Santa Clara County Parks for 18 years. Karen is a familiar name to many people in the chapter as someone passionate about environmental education and was always ready to lend a hand. Since 2019, she has been the chair of the chapter's scholarship committee, working closely with Paul Heipel to ensure a smooth transition after Nora Monette's retirement. Karen has been involved with all aspects of the scholarships, and I'm just going to give you an idea of what it takes, from initial outreach to students and faculty, to sorting applications and sending them to other committee members, evaluating the applications, responding to the applicants, coordinating with the treasurer to get the scholarship checks out, submitting write-ups to the Blazing Star newsletter, and finally organizing presentations by the students, such as what you're going to see today. Karen often keeps in touch with the winners and sends them job openings. Programs like today's are months in the making and involve inevitable scheduling changes. Karen has done all that behind the scenes to bring you this program today. Karen also served as Rare Plant Chair during 2020 to 2021 and participated in the Rare Plant Committee prior to that. She teamed up with the late Don Mayall to conduct rare plant treasure hunts in Santa Clara County parks. Karen moved to Sonoma County in 2021, and she continued her work on the scholarship committee. Her efforts have benefited not only the students, their professors, but also the chapter at large in highlighting current areas of research and chapter support of those efforts. As Karen steps down from the scholarship committee, we wish to thank her for her tremendous contribution and offer our best wishes for the future. Congratulations, Karen.
Thank you. That was very unexpected. So, and it looked like you looked at my resume there, my old resume. Thank you so much. It really has been a joy reading the students' applications because they're so creative. They're so passionate about their work. So it wasn't hard. I'm only sort of stepping back because I'm so far away from you guys now, and I need to maybe get more involved in the Milo Baker or Sonoma County chapter. So thank you so much for this. It was very unexpected. Thank you.
You're welcome. Thank you, Karen.
Well, thank you, Arvind, and thank you, Karen. Oh, please go ahead, Karen.
Well, Maureen was trying to get your attention, I think, a little while ago. I don't know if she was like having trouble with YouTube or what.
I think Madeline said she's having some trouble with delayed slides. Madeline, go ahead and just speak up.
Okay, yes, the slides are delayed on my computer. I don't know on YouTube. I don't know if that's true for other people. So just sometimes that happens. And secondly, the photo group meeting has been moved to Friday, the 19th because of Memorial Day weekend.
Oh, okay. Thanks about that. Thanks for letting us know. I will, sorry if I got that wrong on the slide. Okay. Well, so now it is time for our main event, the presentation from our scholarship students, and we'll be starting with Krti Tallam, who is a PhD candidate and transdisciplinary expert for planetary health topics via machine learning and computer vision, data science, and science communication. And she is at Stanford. And Krti, I'm going to turn it over to you.
Okay, thank you so much. All right, I will go ahead and start sharing my screen. Okay, I think I should make that full screen. Okay, does everyone see like a full, just my first intro slide?
Looks good.
Perfect. Okay, and folks can hear me okay. Let me know if you can't hear me, and I think we'll do questions at the end. But hi, everyone. My name is Krti Tallam. Thank you so much for the introduction. Thank you for the scholarship, CNPS, and for the opportunity to continue doing the native plant work that I have absolutely fallen in love with doing. I'm a PhD candidate at Stanford University in California, and in Palo Alto. And today I'll give a little bit of an introduction to a much bigger project that I'm going to have the time to talk about, but I'll give a little portion of it today. And the title is Coastal California Seagrasses are Global Blue Carbon Habitats for Climate Change Mitigation. So I'll start us off kind of in marine waters, and then I think everyone else will take us back to land. Okay, oops. All right, I'm going to minimize the video. So if there are things that I don't notice, somebody feel free to interrupt me and let me know. Okay, so going a little bit into this project, I first sort of want to thank my colleagues as well from Stanford, Cal Poly SLO, Cal Poly San Luis Obispo, the Morro Bay National Estuary Program, and NOAA and others for supporting this ongoing massive multi-pronged endeavor. I know it's a unique thing, and I'm super appreciative of CNPS seeing this to have a native plant theme be in marine environments, but I think that there's a really interesting case to be made here. So I'll start kind of in estuaries before I go back into plants, but estuaries are essentially these critical interfaces between freshwater and marine environments. And I got really interested in them in the context of climate change because I thought, oh, here's a system that we can sort of look at different aspects of dynamic landscapes and still look at plants and still look at health and ask climate questions. So although our understanding of the ocean as sort of like being a carbon sink and being very important for success and health of ecosystems, the fate of organic carbon fluxes in coastal environments kind of remains uncertain. One of the ways that I looked at studying that was through a plant known as seagrasses, and they're not kelp and they're not seaweed, which often people don't always know, but they're a major native plant constituent of ocean flora and found along global, actually temperate and tropical coastlines. And they provide habitats for organisms. They filter sediments, they store carbon, they attenuate wave energy and filter water column, the water column of pathogens. And so they're a really interesting case study. And I picked a specific species native to California called eelgrasses. Zostera marina is the scientific name. And so bringing this more now to my study examines the ability of Zostera marina, which I'll now be calling eelgrass for the rest of the talk, a type of seagrass, to act as a blue carbon habitat. So most of the time when we think of blue carbon, we know that tropical forests and temperate forests have that ability. We are now beginning to tap into wetlands, mangroves, and estuaries as blue carbon habitats. So there's a little bit of what I'll focus on today. Oh, and I thought I would define that as well because that's a term too. So blue carbon habitats are basically habitats that store more carbon per unit area than terrestrial forests. In addition, I went ahead and I developed a preliminary novel machine learning image classification algorithm using remotely sensed data to analyze the total eelgrass acreage per site and per estuary. I did this on multiple estuaries as a function of total organic carbon. And then I analyzed patterns of estuary-specific proximity to other vegetated habitats that are contributing to organic carbon storage. I'm not going to be able to talk about all of that today, but I sort of wanted to give a sense that we had this pronged approach where we had drones, we're flying them over landscapes, gathering this remotely sensed data, building an algorithm to analyze that and to look at carbon from that landscape. Oops. Okay, and the bigger picture is that this would help answer fundamental scientific questions and how one of the most widespread coastal habitats and native plants on Earth can serve as a critical buffer against coastal climate change. So this project is a unique broad-scale examination of meadows, seagrass meadows, basically just bundles of seagrasses across distinct estuaries. We picked San Francisco Bay, Elkhorn Slough, and Morro Bay. I'm only going to focus on Morro Bay today. So if you look up here, you'll see the county of Morro Bay, and you'll see the actual estuary that we focused on. But it's an estuary located along California's central south coast. It's actually one of only 28 estuaries that the United States EPA, Environmental Protection Agency, has designated as critical to economic and environmental health of the nation, but it's also seen a dramatic loss in its eelgrass habitat. It was once dominated by eelgrass, actually, and so the eelgrass at this site has declined by more than 95% from 2007 to 2017, which is incredibly dramatic, as we all know, in terms of how our environment works. So with all that context, my study, and I should say our study with the team I'm working with, combines three components: intertidal eelgrass ecology, drone-based data collection, as I already gave a little bit of preliminary conversation too, and machine learning based processing for big data. And the only reason that machine learning really has to come in is because we're working with terabytes worth of image-based data from these estuaries. So we needed a way to large scale process them and rapidly process this data. In other words, to monitor and manage small scale estuary change, there's a need as well for high resolution, accessible, and repeatable methods for detecting, measuring, and modeling the dynamics of eelgrasses and other species. So I'll talk a little bit about what we did today. We took this machine learning model, which is a subset of predictive computer science that basically where a model trains itself to make decisions over time. And we applied it to estuary-wide drone imagery, which basically means we applied it to the whole estuary. So if we look here, this is the entire estuary of Morro Bay. Estuaries have a mouth where basically they meet the ocean. We have salt water flowing into the estuary, and then they kind of end here. And not all of them are like this, but this is a case where it sort of ends. And so you have fresh water like at one end, sort of, and salt water at the other. So it's a very interesting dynamic landscape, so to speak. And we demonstrated a high model accuracy, which basically means a strong model for the classification of eelgrass patches or eelgrass meadows of Morro Bay relative to the way humans classified them. So all we were trying to show was, hey, we have an algorithm that can sort of tell us about blue carbon a little bit faster than if we were to do this manually. We've been flying drones since 2017. I will say that I was not a part of that. I only came on in 2019 and I've been working with the team's data from 2018. So we've kind of left out the 2017 data. But each year, we noticed that the intertidal eelgrass beds showed a lot of variation. And so we have this running record now of how eelgrass beds have changed over the last 5 years. And that can bring in this carbon conversation very easily. To get a little bit into the model, which I don't want to get too into, we basically just labeled a lot of these patches, as you see up here. In the this panel, we basically wanted to show how detailed the human annotation was. So we had people actually annotate this data for us, which was a big part of this. And then I'll go a little bit into what it looks like from the machine's angle as well. So we had humans do this. We looked at the variation, we divided it into classes, which included eelgrass, sand, water, macroalgae, and urban landscape as well. Okay, oops. Okay, so I just wanted to briefly show this architecture. I'm not going to talk much about it, but we used a machine learning algorithm known as a convolutional neural network. Convolutional neural networks and neural networks really are basically good for image-based processing, and they work well with plants because you can sort of like distinguish them from sand and from water as well. And the goal here was we labeled every pixel of an image with a corresponding class of what was being represented. So we're able to accurately say, oh, okay, this is how much eelgrass meadow exists at this time of year, at this point in time. And so zooming out now, right, in this study, we've taken this technique, applied it to high resolution drone-based data in Morro Bay, in an estuary that has undergone unprecedented declines of eelgrass over the past decade. And so this method presented here basically allows us to track eelgrass dynamism over seasonal and interannual timescales in Morro Bay, but also in other similar systems across the entire Pacific coast. And I'm now applying this model to Elkhorn Slough, which is sort of located in Monterey, California, and San Francisco Bay, sort of located by, Point Reyes is really where the site is that we're working in, which is located by San Francisco Bay. But the interesting point here, right, is that these ecosystems store carbon mainly through sedimentation, and seagrasses will reduce the energy of ocean waves, slow down the flow of water, cause sediments to accumulate. And then these sediments trap organic matter and other sources of carbon and kind of keep it from re-entering the atmosphere. So there's this very interesting concept where before we can even solve the carbon problem, we sort of even had to look at where are eelgrass showing up in the bay and where are they showing up over both spatial and temporal scales. And so now that we have a deeper understanding of that, and I'm sorry, I didn't explain this. This is the machine learning model's output, where we're able to give this to a think tank or a scientific organization and say, hey, this is exactly the detail level of eelgrass, within your estuary. And then if you take this over 5 years, you can easily visually see the change, but also quantitatively see that because our models give us numbers. But now that next step is we're beginning to discover that areas without vegetation are more likely to release stored carbon when they're disturbed. And so that's kind of a next part of my work, is to say, okay, what does this mean for the carbon implication? What does this imply for carbon in the way that I've been talking about it? Okay, and then that's it. I kind of wanted to keep it short so that I could leave room for the other speakers. I don't know if I went over time, but I'm happy to answer questions later. Thank you.
Hi, that was great. We don't have any questions at the moment. Madeline, do you have anything?
No, there were no questions on YouTube. I was going to ask one, but you defined all your terms, so thank you very much.
Thanks.
Thanks, Krti. That was a great presentation. So if there's no questions, let's.
Wait, we have one
right.
coming in, late breaking question. Do you know why the decline is occurring?
Yeah, and so that's a great question, actually, because one, there are multiple reasons. So we're looking at something called eelgrass wasting disease. There was this outbreak in the 1950s and 60s, and then in the 90s. But in the 50s and 60s, along the Northwest and Atlantic coast, about 90% of the eelgrass was lost. And the identifier was this parasite called Labyrinthula zoster, which was apparently killing off seagrasses in like this massive scale. So right now, that's kind of one of our, yeah, that's a good question about water clarity. I'll get to that. But that's right now, one of our hypotheses about the decline. What's interesting, though, in the last 2 years is that they've actually started coming back in certain patches. And something I didn't talk about was intertidal versus subtidal seagrass. Intertidal is where your feet are standing on the beach when you go to the ocean, and then the sub is where you're swimming in the water. And that's like my way of defining that. But it is basically my short answer is a very complicated question. We think it's a disease. We think climate change could have to do with it. That's another part of my study that I didn't get to talk about today. But yeah.
So we have a couple more questions actually came in while you were answering, and I think we'll just stick with those and for time. So there's a question about the water quality affecting the data. Did you get that?
Yeah, Ronald, that's a really good question. So, and I'm assuming I'll rephrase just for the sake of time, that what I understand you saying is like, if water is turbid and I'm flying a drone over it, will I have trouble seeing seagrasses? I'm hoping I got what you said. Yeah, definitely. And so that's why I focus on the intertidal zone. And we only fly when we're at low tide or zero tide. And so tide is basically receded at this point. Seagrasses, there's so much I didn't get to contextualize here, but they're plants that can survive for hours without water as well during low tide. And so that's the point at which we capture and fly these drones, and it's easier to see that.
Do we have time for more questions, Vivian?
Yeah, I think we could take one or two more.
Okay. Do you have anything? I don't know if you covered this, but there's a question about invasive eelgrasses. Yes. Can you say anything about that?
Yes, I can actually answer Maria's real quick. Yes, Maria, it is, with some caveats of defining the machine learning classes. And then Helen, yeah, there's something called Zostra japonica. Japonica is a species that I think came from parts of Asia and was brought over unnaturally. And so that's been a problem off of the entire West Coast, actually up to Alaska and down to San Diego. And so, yeah, I'm not measuring that right now. Japonica is actually like very stringy. So it kind of sometimes gets mixed up in our machine learning classes, kind of to Maria's question, where I have to redefine a class before saying like, oh, this is a different species, and then I can look at that. So I haven't done anything with invasives yet.
Terrific. Well, this is just a first kind of presentation, and we look forward to the rest of your research and the results later on in the future. Thank you very much.
Yes, thank you very much. All right, next we have John McLaughlin, who is a master's candidate at San Jose State, and he has spent the last 3 years studying the bryophytes at Henry Coe State Park and developing a guide. And John, I'm going to turn it over to you now.
Sure thing. Thank you for having me. Let me just pull up my slides and then I'll share my screen. Right. Can everyone see that okay?
Yeah,
All
looks
right.
good.
Great. Let me put this to the side so I can see everything. All right. Well, yes, thank you for introducing me. Yes, it is my last semester working on this project. But yes, I am a master's student at San Jose State University in the Carter Lab, and I've been studying bryophytes, and specifically the bryophytes of Santa Clara's local Henry W. Coe State Park to produce a flora. So let's hop into there. So let's define bryophytes first. Some people might not know what they are. So bryophytes are plants. They consist of three main groups. You have your mosses. Here, you have your hornworts and your liverworts. And so bryophytes are really interesting for a lot of reasons, but for one is that they are ancestor to all extant land plants. So they're the first land plants to evolve to, first plants to evolve to grow on land. As well, and one of the biggest takeaways for bryophytes is the fact that they are understudied often and overlooked compared to higher plants and vascular and flowering plants. And this is especially true here in California, where we can see over the last 50 years, looking at this figure from Carter et al. 2014, that the rate of discovery in the Western states, so this trend here, is steadily increasing, whereas in the Eastern states, the rate of discovery of bryophytes has plateaued off. So it goes to show that this area of studying bryophytes in California and in the Western states is still very much an active area of research, and there's still much to discover. This can be attributed to many biologists and botanists over the last 50 years, but one of those is this individual here, Dan Norris, which most people might be familiar with. So I'll begin to hone in on my study site. So Henry Coe State Park lies along the interior coast ranges of California. It's about an hour and a half southeast of San Jose. So this range is also called the Diablo Range, and a smaller subset of that, where Henry Coe is called the Mount Hamilton Range. So Helen Sharsmith in the 1940s published a vascular flowering plant flora of this range, and she found that there are many rare and endemic vascular species here. And in more recent times, there's been research to show that this area, this Hamilton Range, is a conservation priority under all three metrics that this group studied from Kling et al. 2018. So we know for a fact that this state park in this area of California is very botanically interesting and important to study, yet very little is known about the bryophytes there. Also important to note is that this range in this area, California, is largely dominated by foothill woodlands and chaparral ecosystems. So a little bit more about Henry Coe State Park. It was established in 1953. It's around 87,000 square acres, making it the second largest state park in California. Most of the park, maybe about 2/3 of it, is in Santa Clara County, while the eastern edge of the park is in Stanislaus County. And before I began researching and studying the bryophytes here, there are only 180 collections of bryophytes from the park, with the total species count of 90 species. So from these numbers, we can say that this is pretty compared, relative to the area and the land size of this park. It's understudied for sure. So the objectives of this study is to comprehensively inventory the bryophytes of Henry W. Coe State Park, with the focus on understanding its diversity, the distribution of these plants in California, and the conservation implications. Now, sadly, I know we are on a schedule today, so I don't have time to talk about everything, but I will be defending my thesis within the month. And so if people would want to hear a longer, more drawn out presentation, I can certainly share that with you after the presentation. So moving on to my methods. So like Vivian mentioned, over the last 3 years, I've been out in the field in Henry Coe collecting mosses. And so you can see me here with some other biologists, me staring in the distance. And so basically what we do is we bring all these packets out with us, and we collect bryophytes, put them in there, and we eventually then bring them back to the lab, and we identify them using microscopy. So mosses and bryophytes as a whole are very small organisms, so you need microscopy to identify them in most cases. And once we have a name for these plants, then we put them into permanent packets and we store them in herbaria. In herbaria, they'll stay for for forever, if possible. And people can continue to research them while in this preserved state. So I do have some results since I've been working on this for some time now. So up to date, there's around now a total of 1,500 collections from the park. And the map to the right here, you can see the black dots are all the places I've collected from, and the white dots are all the historical collections. So the species count has now increased to 177 species. This includes 153 mosses, 20 liverworts, 4 hornworts. This is generated around 91 county records, so these are species that we didn't know existed here. And then potentially 3 tentatively undescribed bryophytes. This is a new figure I just created recently, but it shows the accumulation of species over time. So we have a number of species in the y-axis, a number of collections over time. And we can see here throughout the years that I've collected, so 2021 to 2023, there's been a steady increase in the number of species we know here. And then you can see also the historical collections are quite small, represented by 1993 to 2020. But this graph goes to show that this flora in my project is, well, preliminary, because the curve itself has not plateaued off. And so there's still lots of possibility to see more species that we have not found yet in the state park. Also in the state park, to quickly discuss, there are a number of different floristic elements. So Henry Coe kind of exists in a transitional area of California. So we have lots of introduced taxa being in close proximity to the Bay Area. We also have our typical Central Californian flora. We have things that extend over from the immediate coast ranges like Santa Cruz Mountains. We have a few montane floristic elements, as well as we have some desert and some drier, Southern California floristic elements. And so these are just the species that are more commonly found there that make their way up to Henry Coe. And now I get to show you some nice pictures of mosses. So Proteaceae is a family of mosses, and this is the richest family, so the most species-rich family in the park with 45 species. And here are some of those. Some of these species are annuals, so they're hard to catch and hard to identify as being very small sometimes. And the second most species-rich family is Bryaceae. This family is very interesting for lots of reasons, but it's definitely an active area for taxonomy in this family. A number of recently described species are common in Henry Coe. The 3 undescribed species are also in this family, as well as the introduced, maybe around 3 of the 6 introduced species we have at the park are in this family as well. So lots to talk about within this group, but not enough time today, sadly. And of course, I can't forget about the liverworts and hornworts, the often forgotten members of the bryophytes. And here we have about 24 total, so 4 hornworts and 20 liverworts. And so this may not seem like a lot, but in terms of hornworts, there are only 8 hornworts known in California. So Henry Coe has half of the species known from the state. And whereas liverworts, we don't have as many as compared to the wetter areas of the state. But in terms of the species that are quite dominant in the park are the richias. So that's the species in the bottom right corner here. And this is the most species-rich liverwort family in California. And so it's unsurprising to see that it is the most species-rich family for liverworts in Henry Coe State Park. And that's all I have time to say today, but I just wanted to thank all of the contributors to this project, as well as Santa Clara Valley CNPS chapter. Thank you.
Thanks very much, John. We have a couple of questions. So first of all, what time of year is best for collecting bryophytes, especially annuals? But I don't think you quite consider bryophytes that way, but.
Yeah, well, it's an interesting question. There are annual bryophytes, certainly, especially here in Mediterranean climates. That's where their annuals really become species rich. And so the best time to collect them is going to be winter and early spring. It's getting pretty late for those guys now. They're probably already fried, despite the cloudy weather we've been having. But we can always keep our fingers crossed, as I'm going out this weekend, so we'll see.
It's not always easy to travel around Coe in the winter, though. You
Yes.
put in a lot of miles. Did you do it by car or by truck or on foot or?
Good question. Yeah.
Mule?
Yeah, absolutely. So luckily I have a four-wheel drive car. And so, yes, I've been able to drive through many areas of the park, excluding the wilderness area, which is prohibited to drive on, but also lots of hiking and camping and backpacking as well. But when I can drive, I certainly make that choice. But yeah, in the winter, everything's pretty flooded, hard to get over the creeks. So at that time of the year, you're restricted by foot. Yeah.
Are there any species that appear to be solely found at Co?
There is one species that that people have claimed to have found in California, but those specimens have since been understood to be misidentified. So this species is called Aloina rigida. It's much more common in Southwest United States, so like New Mexico and Arizona. And so we're still getting some confirmations to see that this is the only collection of it in California, but it is certainly a rare species in California, if nothing else, if not technically new to California, and only in Henrico.
All right. So what is it about the ecology of Co that supports such a diversity of bryophytes? And I guess I had a follow-up question on that. Have similar collections been made elsewhere in the Diablo range? Would it sort of be typical of the rest of the Diablo range, or is Co special this way?
Well, there's a few things. I think it's definitely a complex question to answer, but a study in 2021 looked at the bryophytes of Mount Diablo State Park. And so we share a lot of the species that they have there, but there are some differences. They have definitely a stronger maritime influence. So they have bryophytes that we don't have because of that extra moisture. But because of the size of the park and the way that it spans from the western part of the Diablo Range to the eastern part, we can kind of get an all-encompassing range of species, things that are crawling in from San Joaquin Valley, and like I said earlier, things that are creeping in from Santa Cruz. And so because of the size of the park, it really helps in the sense of boosting that species number, as well as it's relatively untouched and a well-preserved park, despite the wildfires. Bryophytes are really good at hiding in crevices and in canyons and existing as like relics in those areas.
You know where to find them. Last question, do you find bryophytes in both wet and dry habitats?
Yes, absolutely. Yeah. People like to think that bryophytes are really, they're really big and like, juicy bryophytes we see in wet areas. But most of our diversity comes from the dry lands of the park. But these often are really small. And unless you know what you're looking for, you're going to have a hard time seeing them. And that's why I said, a lot of these things get to go to the lab. And it turns out you have more than one species that you collected, and it becomes a whole process. But yes, many bryophytes grow on bare soil and exposed habitats, bare rock and full sun. So they are really tolerant and desiccation tolerant species.
I guess we have another question, follow up on, you mentioned the wildfires, which affected Co several times, especially in the 2020. Did they affect your study?
Yes, certainly. Certainly the eastern part of the park was the hardest hit by the fires. It is recovering well in most cases, but for these areas that have been burnt, it's hard to say that we have a comprehensive understanding of what species exist there. Like I said, there are the wet areas, the riparian areas that are more well preserved, but I think it'll take some time, and hence the title preliminary. It'll take some time to really say with confidence that we have a full understanding of the park because of the fires and because a lot of the saxiculates, so like the rock growing mosses and the tree epiphytes, those kinds of mosses got burnt by those fires pretty severely.
Okay, I think that's it. Well, thank you very much. Appreciate it.
Thank you.
I just realized I have a Co background, so.
Of course, yes, I know. We have talked, Judy, a few times, I remember. Love to see it.
All right, thanks very much.
There is one more question about whether you're going to have a paper field guide.
I do not have a paper field guide in the works, but I mean, I'm sure if there's interest. I take many photos, as you can see, and I enjoy doing that. So it's definitely something I've thought about, and I've thought about maybe making a brochure or something like that. But I will keep everyone in the loop if that comes to light.
Yeah, I'm sure this group would be very interested in that. And please do share your defense link so that those of us who are interested, and I put myself in that category, can watch.
Yeah, maybe I'll send you an email this evening and then you can distribute it. Does that sound good?
Yeah, I could definitely do that. Thank you so much, John.
Yes,
Thank you very much.
Okay, our next student is Sierra Phillips, and she is a PhD candidate at UC Davis, where she is studying hydraulic sciences, and she's focused on river restoration. So Sierra, I'm going to turn it over to you now.
Thank you. Great. Can everyone see my screen? Good?
Yeah, looks good.
Great. Thanks, John. All right, good evening, everybody. Thanks for tuning in this late. I'll be presenting my current dissertation work that's focused on the development of an eco-hydraulic tool to predict the spatial distribution and potential of cottonwood seedling recruitment in the lower Yuba River in Northern California.
Sierra, are you still there? I see other people. Oh, Sierra, you dropped off. Can you see or hear us?
Yeah, I can see and hear everybody.
Okay, I think you might
Can you
need to
hear me?
start over because it froze almost immediately after you started talking.
Oh, no.
We can see your slide just fine, though.
You can't see my slide. Okay,
Yes.
you just can't hear me.
You're fine now. You're good.
Okay.
You froze for a second. You're back.
Okay, great. Sorry about that. So yeah, I was just going to define what eco-hydraulics is because I know it's a jargony type of term. So for those not familiar with it, it is an eco-hydraulics approach essentially strives to connect abiotic and biotic phenomena in aquatic and riparian systems. So while I doubt I need to convince this group of the importance of cottonwoods, some may ask, why should we care about cottonwoods or specifically cottonwood seedling recruitment? So Populus fremontii, also known as Fremont cottonwood, is one of the most important riparian species in California due to its historic dominance of riparian forest in the Central Valley and due to its role as a pioneer species, meaning it has the ability to colonize disturbed areas or new landforms. And while cottonwoods are capable of vegetative reproduction, understanding cottonwood seedling recruitment is crucial for supporting or enhancing our native cottonwood tree populations for the following reasons. Cottonwood seedling recruitment introduces genetic diversity, which allows for a population to survive and adapt to changing environmental conditions. And while riparian plantings are the most common measure in riparian forest restoration projects, native tree planting efforts often fall short of desired outcomes. So this photo here illustrates the challenges associated with revegetation efforts, as it shows failed live stakings at a side channel restoration project on the lower Yuba River. And the last reason I'll share is that there is this need to support more process-based approaches to revegetation. So process-based restoration approaches emphasize designing a habitat with respect to the natural potential of a site by considering physical factors or processes that will impact the success of a design. So analysis tools that model this relationship between the physical and biotic processes are essential to meet the planning needs of process-based approaches to improve the success of those efforts. So the goal of my work is to explore the relative importance of hydrophysical processes that limit or promote cottonwood seedling recruitment. And my approach has been to create a mechanistic model that estimates the spatial distribution of suitable cottonwood seedling recruitment sites. Planning needs of process-based. And to clarify, hydrophysical processes refer to processes related to the physical movement of water. And when I say mechanistic model, I'm referring to a model that applies physical and biological principles with mathematical equations to represent a process, such as seedling recruitment in this example. So this chart represents the overall approach of my dissertation work. We begin with creating a perceptual model of cottonwood seedling recruitment, and then conceptualize the phenomena identified in our perceptual model through defining individual processes. The next step is to create an algorithmic representation of that conceptual model with code. And then the final steps are to calibrate and validate the model with observation data, so we can evaluate the usefulness of the model. I will note that each of these steps is iterative, and I've already experienced the review and revision of these first few steps many times, and I'll be focusing just on these first 3 steps in the presentation, but we'll be coming back to this chart again. So taking a step back to go into some more detail about cottonwood seedling recruitment. Recruitment broadly refers to the process by which a new individual is added to a population. Thanks for review and revision of these first few steps many times. For cottonwoods, recruitment may occur by seed or vegetative reproduction. So we're focused here on seedling recruitment, which consists of these 3 processes: germination, survival, and growth. So successful cottonwood seedling recruitment is episodic due to climatic and hydrologic fluctuations. And there's previous conceptualizations of the relationship between hydrologic patterns and cottonwood seedling recruitment, including this recruitment box model, which was first described by Mahoney and Rood. And the recruitment box model essentially integrated previous findings related to significant hydrologic components, patterns of seed release, and physiological tolerances relevant to successful cottonwood seedling recruitment and survival. So past applications have mainly focused on in-stream flow recommendations to conserve and restore cottonwood populations, with successful examples on the lower Truckee River in Nevada and the Kootenai River in Idaho. So these are regulated rivers that have dams in which they would be able to modify the flow regime. And these previous conceptualizations and applications have been very influential in my own process to develop a model for application on the lower Yuba River. So that is why I felt like it was important to take time to talk about this. So when thinking about the process of seedling recruitment, I like to imagine a story beginning with a cottonwood seed luckily landing on a proper location for germination. So the first thing to consider is that a cottonwood seed cannot recruit successfully if the surface is already occupied by vegetation. So a suitable location for a seed needs to be unoccupied, or a scouring flow during a flood event needs to mechanically remove existing vegetation to make it unoccupied. So this is what I'll be referring to as bed preparation. And then cottonwoods are unable to maintain a seed bank due to their limited viability. And so the timing of seed release and finding a suitable site is critical for germination and results in high mortality at less suitable sites where moist substrate is not present. So this next period is, I like to think of it as a race between how quickly and deeply a seedling can grow its roots to keep up with the receding water table as the stage in the river recedes to prevent desiccation. And then seedlings also need to survive prolonged inundation periods, and they also have the threat of being pulled out or damaged by scouring flows. So each of these processes can then be related to an element of the hydrograph. So bed preparation will occur during peak flood flows in winter that have the greatest capacity to move sediment or move rocks in a river. And then germination will occur during the spring recession period when mature trees are dispersing their seeds. The recession rate period will start with establishment and continue until base flow conditions in late summer. And then the inundation, prolonged inundation survival can occur anytime after germination if a seed establishes too close to the channel. And then the last being scour survival, which can also occur during any point after germination. And what we're thinking about here is the subsequent peak flood flow event, similar to bed preparation. So taking the perceptual model, I then created a conceptual model. And I used a similar approach that was taken by Benjankar et al. In 2014 and 2020. And so I won't spend too much time of talking about exactly what equations were used for this conceptual model, but essentially for bed preparation, we're estimating it with what we call dimensionless bed shear stress during this period before seed dispersal, which determines if sediment or a rock of a certain size can be mobilized for a given flow. And then we estimate the area where we would expect germination to be either calculated with the wetted area during seed dispersal where moisture would be available, or with set elevations where cottonwood seedlings have been previously observed to establish. The recession rate is estimated with interpolated water surface elevations to mimic the fluctuations of the groundwater. And then the inundation survival is tracked by calculating the successive days where the water surface elevation is above the ground, and scour survival is evaluated similarly to bed preparation. But in this time period, high flood events that mobilize sediments is a threat to the survival of the seedling rather than being a positive thing to prepare the bed. So these 5 processes are what we'll be using to evaluate the potential suitability of a site for cottonwood seedling recruitment. So I won't spend too much time on the algorithmic model, but this is just the simplest schematic that I've been able to make to represent what is now the riparian seedling recruitment module. So essentially this process was just taking that conceptual model and then representing it with equations and writing that in Python. So, Python is a programming language for those who are not familiar. So here's an example of what the spatially distributed results look like. So this is what the combined recruitment potential map looks like for a site on the Lower Yuba River as an example. So areas with optimal conditions, meaning all of these hydrophysical processes created ideal conditions for recruitment, they're shown in dark purple. And so these are the locations we can expect that cottonwood seedlings are able to successfully recruit for a given year of interest. And then areas with lethal conditions shown in magenta indicate that at least one of the 4 hydrophysical processes that we've been talking about here created conditions that would not allow for either germination or created a lethal environment for that seedling. And then the areas with the values in between represent stressful conditions where seedlings may be able to successfully recruit, but we would expect a decrease in density due to the stresses they in. So as a lab group, we believe it's important to share not only new methods, but also to make the application of tools like this riparian seedling recruitment accessible to river managers, restoration practitioners, and stakeholders. So the tool is now integrated into our lab's open source software, River Architect, and the web page I shared here will take you to our website where you could find the wiki for the tool if you were interested in learning more about the details of how this tool was created and the equations and all, if you'd want to use it even. Oh, sorry. So this is what the tool actually looks like when you open up the riparian seedling recruitment tool. So this is how we made this usable interface. So anybody who doesn't have any sort of coding experience can utilize one of these tools. So the recruitment criteria worksheet can easily be opened and allow the user to modify the model parameters that would best represent a specific site for analysis. And what I've done for my application is specifically for Populus fremontii, but it could be created for other species of cottonwoods or possibly other trees that have similar recruitment patterns. So creating a more complex model doesn't always ensure that it's an accurate or useful one. So evaluating the model structure and parameters are important. The next steps for me are to calibrate and validate the model with observation data collected on the Lower Yuba River last summer in a campaign that was led by my lab mate, Rachel Wright. The model calibration stage will begin with the exploration of the model parameter sensitivities, and then I'll utilize calibration algorithms in order to determine an optimal and realistic parameter set. And then the result of this analysis may tell us that additional field data is necessary for estimating parameters, or that a more simplified model can provide useful predictive accuracy. So once the model is deemed useful, I'll be applying it on the lower Yuba River to answer my overall question of what is the relative importance of hydrophysical processes promoting or limiting cottonwood seedling recruitment on the river. So thank you, CNPS, for your support and for the opportunity to share my work with you all tonight. And I also just wanted to share the references that I had during the presentation for anybody who's interested in looking into that more.
Thank you very much, Sierra. That was great. We have a couple of questions. I'm not sure if Karen's, I got John also giving you the clapping. So I don't know if this, Karen, if you want to unmute yourself, I don't know if your question is still, if she covered it at the end there. Has your algorithm been tested on the Yuba yet? Is the Yuba controlled by a dam? So I think you were sort of got to that a little bit after the question was posted.
Yes, so the lower Yuba River, and I apologize for not going into more specifics about the lower Yuba River itself. The work so far has been, the results are the model at this point. So future research is ongoing, and I'll be happy to share the results of when we finally do apply it on the river. And but yes, the lower Yuba River, to give some background on that, it is regulated by a large dam. So, and the Yuba River itself has multiple dams on it, but the specific area that we are studying is under Englebright Dam.
I always think it's great. The students who come here always have sound very polished and have all these great slides and stuff, but we know you're just in the middle or starting your project, or maybe closer like John was, but you're not done yet. So we don't, we understand that. Are people planting cottonwood seedlings to restore the river?
So specifically seedlings, I think they prefer to, from what I've seen of projects, so there's tons of restoration projects happening on the lower Yuba River specifically right now. If you were to Google the Hallwood project, that's a huge one. And from what I understand, on a recent presentation I just saw at SurCal, they did a lot of pole cutting. So they're trying to get that vegetative reproduction to happen rather than doing potted plants of any sort, and definitely no seed dispersal. So yeah, that's the kind of the drive here, to try to understand where we're finding recruitment on the river naturally, so that maybe if we just provide the right conditions for these trees, they can populate themselves rather than us having to go in and do these really intensive planting efforts.
A question about the source of the raster images. Oh, that's from the YouTube. What is the source of the rasters / images? Is it satellites?
So the rasters, specifically with the results of the model, that's from the model. And so those are created with, they stem mostly from the hydraulic rasters that, so I had to run a large amount of flows for the two-dimensional hydraulic model to simulate all the flows that we'll see for a year of recruitment that we're interested in looking at. For just the aerial images though, yeah, that's just satellite imagery, but we also have drone imagery from some years, so different sources.
Good. And when Karen asked if did you say the Hallwood project?
Yes, the Hallwood project, exactly.
Okay. And if Karen had a follow-up on that question or not. But Madeline, is there anything else on your end? YouTube? I think we got him.
Great. Well, thank you. And I apologize for the technical difficulties at the
very
beginning
minor,
there. I hope not too much was cut off.
No, very little. Very little. It was fine.
Great.
It was good.
Wonderful. Thank you again.
Okay, thank you. Thank you, Sarah.
Yeah, thanks, Sarah. Whoops. Sorry, I'm having trouble getting to the right screen here. Hey, our last student of the evening is Andy Frank. He's also at San Jose State, where he is studying Erysimum franciscanum, using it in a greenhouse experiment. And Andy, I'm going to turn it over to you now.
Great. Thank you very much. Let me share my screen. Okay. Can everybody see this okay?
Looks good.
Good. All right. So my name is Andy, and I'm a master's student at San Jose State in the Carter Lab with John. And tonight I will be presenting on Erysimum franciscanum, which is the San Francisco wallflower, and specifically my research proposal, which is to look at the different populations and their growth responses to different water availabilities to determine if they are locally adapted based on water. So just some background information here. Erysimum franciscanum is a biennial to semi-annual subshrub. It's found on serpentine, coastal scrub and sand dunes, granitic hillsides. There are two proposed varieties, crassifolium and franciscanum by Rossbach from 1958. And just some background morphology here. It's oblanceolate to linear, flat and hairs on its leaves, and there's a very striking and notable flower color gradient from cream to yellow. And the left photo is photo of a plant from the Presidio population. Let's see. Okay. So yeah, I wanted to pay homage to this really great flower color gradient because this might be how many of you are familiar with this plant. It is not what I'm studying. I'm not studying the flower color, but I wanted to talk about it because clearly this species has really unique properties, and it's really interesting that it goes from white to a combination of white-yellow, San Bruno Mountain, to yellow Crystal Springs and further south. And so these are just some photos of the plants from the different populations side by side that you can see. And so clearly there are some really interesting aspects to the locally adapted populations, and I just wanted to highlight the uniqueness of this species. So here are the different populations that I'll be looking at throughout the Bay Area, ranging from the Presidio all the way down to sort of the South San Jose, Morgan Hill area. And as you can see, there's just this really nice like latitudinal gradient that goes from north to south, and the flower color actually follows that latitudinal gradient, just like something interesting as well. Goes from white to yellow north to south respectively. Here's the larger range. As you can see, it stretches north into Marin and into Point Reyes, as well as to the coast down to Santa Cruz. And I wanted to bring this up because it's sort of the reason why I wanted to look at water and how this plant responds to different amounts of water. This is the difference in annual precipitation for the different sites that I'm studying, but the maximum amount of rainfall, I'm sure that everybody knows, is very different from an area like south of San Jose all the way up to Marin. So also in the Bay Area, there's a really amazing interannual variation in precipitation. I mean, I don't have to tell everybody that it just rained last weekend, and this year has been so like humongous with the amount of rain we've been getting. I believe on average, the variation is something like up to 20 inches, which is just a huge difference of water seasonally, and California plants depend so much on annual water. So yeah, so just the combination of the range of this plant, being that it's situated pretty much like primarily in the Bay Area, and seeing that we have this like really unique interannual variability in precipitation made it a very interesting case study for a plant species. Also, to date, there have been no published studies on Erysimum franciscanum as the study species. So that sort of has led me to a few different questions in my hypothesis. The first question being, are these Erysimum franciscanum populations locally adapted with respect to water specifically? Second question being, do the populations have specific tolerances to soil moisture level percentages, and is that expressed through their growth responses? And third, will these populations respond differently to future climate change scenarios? So hopefully this research will help us understand the populations, their threshold for tolerance of drought, how the population might behave given certain water availability scenarios. So ultimately, my hypothesis, which seems very straightforward, is if these populations display significant growth responses that are different under various watering treatments, then the populations are locally adapted with respect to water availability. So that sort of leads me to my very interesting greenhouse experiment here. I'm proposing 8 different treatments with 4 populations, 10 plants per population, for a total of 3,200 plants under study. And I'll be growing these plants up in the San Jose State University greenhouse. On the left, you can see just like a schematic of the irrigation system that I'm going to be building. The irrigation will be automated, and it'll receive misting to be able to achieve the soil moistures, hopefully within a plus minus of about 5% of the proposed moistures on the left. I was hoping to have had this trial experiment that I'm running this summer to calibrate the irrigation system set up, but logistics reasons, I'm waiting for another project to turn over. So I will be setting this irrigation system up this summer and using a common household plant. I'm assuming I'll use something in the Brassica family to calibrate the watering system and get it ready to actually grow the study plants out next year. So I drew this really wonderful graph, very technical here, as you can see, but I wanted to highlight the larger concept of local adaptation. So on the y-axis, you've got survival. On the x-axis, you've got soil moisture percentage, and then you've got the different populations, SF being the Presidio, CR being Coyote Ridge. So this just follows the latitude south to north. And I'm hoping to achieve results that look something like this, which very clearly show that there are optimal ranges for soil moisture for each population, and that they are locally adapted, which is the difference here between the peaks of the curves. More realistically, though, I put in some data just into a quick Excel spreadsheet to show this is my gut instinct as like a plant person makes me think this is most likely what I'll probably see, which is the 3 populations, sort of the northern part of the peninsula, I'm assuming will have a lower drought tolerance than the Coyote Ridge population. And I also am sort of expecting to see that the Coyote Ridge population might actually have a higher tolerance for higher moisture availabilities, because sometimes plants that are adapted to drought will seize on opportunities with more resources. So this is sort of what I'm expecting. This is a little bit more detail. So in conclusion, if we do see local adaptation to water, this will definitely help us better understand how populations of this plant will react to future drought scenarios. And if we don't see a response to water, let's just assume maybe the curves are all lumped all together really nicely. Well, that's also really helpful information, because then we can understand the species as a generalist. And it can lead us to some really great future research that are going to look at different factors that could possibly explain local adaptation, like soil type, and also some future studies that could come from this research could relate to evolutionary capacity of the species and gene flow amongst the different populations. So yeah, that's all I have. Thank you very much to the Santa Clara Valley chapter, as well as my advisors, Carter Lab, and other organizations. And I will take questions.
That's great, Andy. This is a favorite plant of mine, so I was super happy to hear about your research. So let me just Get in here. Oops. Okay. So we have a question from Karen. Can you recommend a place where we could get out and see a lot of these wildflowers? Are they scattered, or do they have high densities?
Great question. The populations that I am studying have quote unquote high densities, but these photos right here are a good example of how high the densities really are. You'll see them sort of like scattered through different areas of the park, but this cluster on the right, which is along the south side of San Bruno, was definitely the densest I saw. This area right here, I included off of Kenyatta. This is right before the exit for Kenyatta Road near Crystal Springs. This one you can just pull over and go see. These plants are just growing right here. They're also growing a little bit down further towards this little pool. And then the white flower is up by the Presidio. I can share those location points if people are interested in going to spot them, because those are the sites that I'll be working with.
And Coyote Ridge hasn't been open to the public except with special access days or dose-and-led hikes, usually.
Yeah.
And this year wasn't open much at all. So
yeah, thank you for that clarification. Actually, the Coyote Ridge population is private, and Creekside Science is going to be collecting seed for me from that population.
Yeah. And blooms earlier in the season, right? Like February.
Yeah, these photos were taken late February, early March.
They look like a little hedgehog when they're in fruit. So I have a question. Do you think the flower color is temperature dependent?
That's a really good question. It's hard for me to say. I can't confidently say either way. My gut instinct would say maybe, but I don't know. Part of me also just wants to say that could be like soil type. Yeah, not so sure about temperature, but it's a good question.
Let's see. Madeline, do you have any other questions on this presentation from the YouTube? Oh, what time of year is plant flowering? I see that there. We just answer that. It's fairly early bloomer. And do you also see the more common Western wildflower in these areas too, or is it just places where this grows? Have you looked into that at all?
I know that there are like small little pockets where it could overlap, but the populations that I've been to, I haven't noticed that.
There's a question about these kind of wildflowers in the Big Sur area, but I believe those are a different species. They're not the Franciscan, correct?
Yeah, the franciscanum, the range is really just like if you were to drop a solid spot over the Bay Area. So
yeah,
south.
That questioner may want to go to CalFlora and look up wildflowers, and there's different ones along the coast, and some of those are rare too. I think up in Point Reyes and so forth. Let's see. I think that's it for right now. Madeline, did you have anything else from YouTube?
You caught them all. I just checking to make sure there's, yep, no more. But there was that late follow on for Sierra if we have time.
Okay, we can do that. If there's any other questions for Andy, I don't think so right now, but it's great. I'm so excited you're working on this species.
Great. Yeah. Thank you very much, everybody.
Yeah. Thanks. All right, Sierra, are you willing to answer another question?
Yeah.
The question is a follow-up. With the long history of mining, I've seen quite a bit of mining tailings on the Yuba, and how does that play into your model?
Yeah, so there are some very large mining tailings on the lower Yuba River, specifically the gold fields. If you look at it on an aerial map, is quite stunning. I guess is one way of putting it, not in a great way. There's also a very large massive training berms is what they call them. But they're just these large berms of gravel and cobble rock. And I wouldn't say that, so these kinds of landforms, they're pretty dramatic with the topographic differences. And the model does take topography as an input, but and that certainly would modify the hydrology or the hydraulics, so like the flow of water through the river. But I wouldn't say that it's specifically like plays a role in my model. Topography definitely does, as I'm trying to explain. And yeah, I would just say, like, from what I've seen of projects on the river, removing the tailings or training berms, it's been a large priority for a lot of these projects. And in general, the floodplain lowering, so lowering those topographies, it definitely improves a lot of natural river processes, and certainly would make it easier for vegetation to grow, just because it's decreasing that depth to groundwater. So it makes it more acceptable for them to be able to access water year round.
Okay, great. We have a couple other questions. There's one person who has a lot of questions for you, so I think we'll just connect you with her or
Okay.
them, and then you guys can talk it out. Because I think at this point, we'll just see if there's any other questions from anyone else, or
Now, I think there was a question for John that didn't get asked by Emma about monitoring substrate and specific bryophyte species. Did that one? I think that one got missed because it came in after the field trip, the field guide question.
I didn't see it.
So it was, do you monitor substrate in specific bryophyte species, and how does rock substrate affect bryophytes that can survive?
Yeah, actually, I answered this question in the chat with Emma, but I'm more than happy to tell everyone the answer. So I do monitor every bryophyte we collect. I make sure to record the substrate it's growing on. And in terms of mineral composition, at Henry Coast State Park, there are no bryophytes that are restricted to certain mineral types, despite the interesting minerals that occur at the park. But there are bryophytes elsewhere in California and in the world that have a strict affinity towards certain minerals. Is that the question? That answer the question?
I don't know. Is Emma still here? Actually, I'm
not sure.
Yes, thank you.
Okay.
Thank you. Okay, good.
Yeah. Thanks, John. Well, I wanted to thank all four of our students, Krti, John, Andy, and Sierra. Those were amazing presentations, and I'm really looking forward to seeing, whoops.
You're okay?
Yeah, I'm okay. There was a weird thing that happened on my screen. I'm really looking forward to seeing what comes next for you. Before we end our session tonight, though, I just wanted to mention a little bit about our scholarship program, because I forgot to do that at the beginning. Our scholarship program, our research scholarship program, is both for undergrad and graduate students that are researching topics that are related to native plant and native plant habitats in the San Francisco Bay Area. We have two named scholarships, though, and I did want to recognize the people who are behind these scholarships, because they're both they were both CNPS fellows with our chapter who did amazing work and support throughout their lives. The first one is Sally Casey, who we have the Sally Casey Shooting Stars Research Scholarship. She was really focused on grasses, and so that scholarship is generally for people who are researching either native wildflowers, native grasses and grasslands, and their soil interactions. And Sally passed away, unfortunately, in 2019, and we still miss her. Our other named scholarship is for Don Mayall. It's a conservation research scholarship, and it's also he was really interested in serpentine, and so that one is usually for a student who's studying rare plants on serpentine ecosystems. And Don passed away in 2017, and we also still miss him very much. So I just wanted to remember them for a moment and highlight our scholarship program. And anyways, that is pretty much the end of our program tonight. I just again wanted to thank our students, and I really wanted to thank Karen as our outgoing scholarship chair. She's put in many hours. She's wrangled lots of students. She's wrangled me getting the talk set up. So Karen, we are going to miss you as our committee chair, and hopefully we'll still see you out in the trails sometimes. And thank you all for being here tonight. And that's the end of our program. So we'll have another program in June. It's just a talk, as I mentioned before, by Jennifer Durking. So please join us again. And good night, everybody.
Thank you. Thank you for your help, Vivian and Judy. Thank you.
Thanks, Karen.
And Madeline and everybody and Arvid. Bye.